For lesson 3, we focus on polynomial identities and factoring. We're going to review a little bit of factoring quadratics, but the main focus, the new material, is going to be to learn how to factor a sum of cubes and a difference of cubes. In order to do that, we need to know what cubes are. But first, let's review a little bit of our Algebra 1 factoring of quadratics that we used a lot last semester and that we are going to be using a little bit today and moving forward. So here is this AC method where we find factors of A times C whose sum is B. Those magic numbers, that magic pair of numbers, let's call those D and E, we can rewrite the quadratic as ax squared plus that sum of D and E x's, that sum that adds up to B, where D and E multiply to give you A times C. Rewriting that quadratic so that we can factor by grouping. Group the first pair, find a common factor, group the second pair, find a common factor, and then continue the process from there. That again is my recommendation. Many of you are trying other gimmicks and stuff that you learned in your Algebra 1 class. If you're comfortable with it, roll with it, do awesome with it. We are going to focus on this method today, and these other ones might not work in some of our extension questions. Of course, guessing and checking is great, but today we're going to have a prescriptive method dealing with our sum and difference of cubes. So if we can follow some directions, do some steps, and I think that that might be beneficial to us. Obviously, I don't want to spend too much time on review, stuff that you've done before, but maybe it doesn't hurt to look at factors of negative 24 that add up to negative 10, would be a negative 12 and a positive 2, so that we can group these things. This pair right here, we're going to find that their GCF is 4 x's, which gives us 2x minus 3. And this pair doesn't have any common factor. Its greatest common factor is 1. And so we have that same pair, 2x minus 3. That's not witchcraft. That's how this process works. Because when we do FOIL, we're taking the first term, 4x, and we're multiplying it by 2x minus 3. And we take the second term and we multiply it by 2x minus 3. So FOIL is double distribution. 4x times 2x minus 3, that's this part, plus 1 times 2x minus 3, that's that part. And that's how we do double distribution or FOIL. And so these, obviously the expectation and the hope here is that you can handle this. Sometimes we need to find a GCF first. This is this has a factor of 5 and x times 4x squared, 5 and x times 9. And so we have a GCF multiplied by this quadratic. But this quadratic we know fits that mold of a difference of squares where we have 2x times 2x minus 3 times 3, which means we're going to take the 2x and the 3 and we will separate them by a plus and a minus. And that is the complete factored form for that difference of squares. I would like for you to try these. And this shouldn't be tried, this should be do. Like you should be able to do those based on the work that we did last semester and the work that you did in Algebra 1. So you do those two. Obviously, we're gonna move on to the next thing. So pause the video as you need to give yourself time to do that. In order to do the new parts today, we need to understand what cubes are. We want to be able to factor a sum of cubes and a difference of cubes. And in order to do that, we need to know what our perfect cubes are. Now, my hope is that you memorize what these are. But in the meantime, if you would like, you can kind of create this list using your grapher. You can say y is equal to x to the third power. And when you make your table of values in there, it will give you all of those perfect cubes. 1 cubed, 2 cubed, 3 cubed, 4 cubed, etc. What we need to remind ourselves of is that cubing is not multiplying by 3. 1 times 1 times 1 is going to be 1. 2 times 2 times 2 is not 6. 2 times 2 makes 4. 4 times 2 is 8. 3 times 3 makes 9. Times 3 more gives us 27. Gives us 64. Gives us 125. Gives us 216. Gives us gives us 343. Gives us 512. Gives us 729. Gives us 1,000. These are our perfect cubes, and I want to make sure that this doesn't come off rude, but I want you to memorize those. Like, I know that we don't talk too much about memorizing, but these are easy things to put on a flashcard and to make sure that you know. If you don't know them, at least know how to get them. Use your calculator, this times this times this. Finding a cube root, working backwards, is a little more difficult. So if you have a perfect cube and you want to find out what it is, like, oh, I know that 125 is a perfect cube, there is a process in your grapher. If you press the math key, The fourth item down is cube root. So math 4, and you can type 125, and it will tell you that the cube root of 125 is 5, all right? So you can find that that way if you would like. But life will be easier if you know these. And that is a memorization thing. And I know that memorization, you guys can memorize the dance moves on a TikTok and the verses on a cool rap. Hopefully you can memorize your cubes. So here is our recipe for factoring a sum and a difference of cubes. If you want to factor these, there's not a whole long process that we have to go through. When we did tic-tac-toe or hangman or guess and check or factor by grouping, there's a lot happening there that maybe was a little bit, there were too many steps for some of us to really manage that well. Well, the sum and difference of cubes, it follows where you have a perfect cube that you're adding together or perfect cubes that you're subtracting one from the other. And so you have your first term and your second term. So whatever that base is, whatever the root is, the cube root of this expression that comes first, that is what A represents. And so we'll have that A, we'll have A times A, and then here we'll have A times B. B, the cube, like what number or expression is being cubed here, that goes here, and that goes here multiplied by itself. Now, you'll notice there's no signs here, and this is our reminder for how to write those signs. So we always have A and B together, A squared, A times B, and B squared, B times B. And then this, so, refers to same sign. This refers to O as the opposite sign. And then the last phrase there is always, the last thing is always positive. So if we have plus, then we're going to have the same sign, the opposite sign, and then always positive. If we have a minus, we're going to have minus, the same sign, plus the opposite, and then the last thing is always positive. This is the factored form for our sum and difference of cubes. These are great things to put on a flashcard along with that little acronym or acrostic there. It's SOAP, S-O-A-P, same sign, opposite sign, and then the last part is always positive. So we're going to use that to do some factoring, and I want to work through these as efficiently as possible for you so that we can manage our time well and effectively. But here we know that we have 8x to the third power, which is 8, a perfect cube, x cubed, 125, a perfect cube. This is 2x cubed minus 5 cubed. 729x cubed, that is 9x times 9x times 9x plus 1 times 1 times 1. This is 3x times 3x times 3x plus 5 times 5 times 5. Over here, this is going to be 5x times 5x times 5x minus 6y times 6y times 6y. So recognizing what the cube root of this term is, that is what we are cubing. That is what we are cubing, and then we have to decide, do we have a minus or a plus in there? All right? So that we can use the recipe. So let's use the recipe, all right? Let's again remind ourselves that we are going to take A minus B times A plus A times B plus B squared. This is going to be the recipe, and this is what your work is going to look like for at least a handful of these first handful. We're going to find out what the actual root is, and then we're going to use these numbers. 2x is A. So I've got 2x, B is 5. So 2x is A. So when I get to A squared, I have 2x times 2x. 2x times 2x is 4x squared. 2x times 5 is 10 x's. And then 5 times 5 is 25. Done. That's it. You can check this to confirm that when you multiply those, you'll get that. I'm not going to use time on that right now, but you can, could, and probably should do that. We are going to have, again, A plus B. We've got A squared, AB, and B squared. We're going to have the same sign, the opposite sign, and then always positive. So I've got 9x plus 1. 9x squared is going to be 9x times 9x, or 81x squared. 9x times 1 is negative 9x. And then 1 times 1 is 1. That's it. Don't make this difficult. Over here, we've got 3x plus 5. 3x times 3x is 9x squared. 3x times 5 is going to be 15 x's. And 5 times 5 is going to be 25. Okay? Now you see what I did there? I did it without writing this formula down. That's dangerous. I strongly advise that we write down our formula until we know our formula. And one of the things that I want to encourage you with writing down your formula is, if you write it down every time, you will know it. Repetition helps with recitation, all right? That's how you memorize the dance moves on a TikTok. That's how you memorize the lyrics to the chorus of the song. When you repeat it, you learn it, and you're able to recite it. Because these aren't going to be given to you always, and so you need to know what these are, right? So 5x's minus 6y's, 5x times 5x, 5x and 6y, multiply to give us 30xy, and 6y and 6y, always positive. So hopefully you can do that work with that sum and difference of cubes. Now, you'll notice that on all these, I did all of these, but here I would like for you to try this, but if you're overwhelmed, we are going to do it in class. And so for these, you're going to have to do a GCF on this one and a GCF on that one. And then there's maybe some nuances there where I'd love to challenge you on this, but I'd also rather talk about these in class. So if you skip these, that's fine. Leave some space, probably about 4 or 5 lines. All right, do that for me, and you guys should be good on that. All right, so then moving forward, we want to talk about maybe bigger picture, how to factor by grouping when we don't just have a quadratic that we're partially done with. And this is maybe a little bit difficult, but if it's already arranged where there's 4 terms and you can see that you can split it into 2 groups just like we did with our quadratics, then you can factor the GCF out of each group separately and move in that direction. All right, so those again are the steps. So have those down. But what I mean by that is, given these cubics, what we can do is I can show you that this and that can be rewritten as a group of factors, all right? A group of terms. And so this group right here has a GCF of 3x's squared times x minus 3. And this, which was a minus 5x, right? So I made it add the opposite, and I put that in parentheses. We have a negative 5 here times x minus 3. Now what's important here to recognize that we end up with that same common factor in both sets. So we have a 3x squared minus 5, and then we have this part that's on the inside, this x minus 3. So that is how we factor these expressions. Go ahead and group some of these. Go ahead and group some of these. If it has a minus sign, be attentive. And let's do some factoring by grouping. When we factor by grouping, again, it doesn't have to be crazy, it doesn't have to be rocket science. What's the GCF here? Well, there's an x squared times an x and an x squared times a 3. Here there is no GCF, there is a 1 is the greatest common factor, 1 times x, 1 times negative 3. But we need to write that 1 so that we can complete the process here. We've got x squared and 1 are right here, x minus 3 are right there, and these cannot be factored further, so we're done. Over here, what do these have in common? Well, here I've got, looks like I actually missed something. So first, my bad, first we need to recognize that there is a GCF. There's an x in every one of these. Factor out that greatest common factor first, and then let's factor by grouping. So here's where another color comes in handy, because we're going to do this, all right? Because it's x times all of that, including this group and this group. So I got double parentheses there. Be mindful of that. So this gives us x again on the outside, but here for this pair I've got a 4x times y minus 5, and I've got a 3. I've got a 3 here times again y minus 5, and then we've got the big parentheses for the outside. Notice how these are the same. That's again is not witchcraft. That's how factoring works, because it's the inverse operation of that FOIL process, of that double distribution. So we end up with x times 4x and 3 and y minus 5. And these factors can't factor more, so we're done. This one we're going to have something a little interesting happen because with this group, I have, let's see, we can factor out an x and a 4. So if I factor out a 4 and an x, I've got 9x squared minus 16. This, we can factor more, all right? And so we're going to see that come into play here in just a little bit. We've got, I'm going to factor out a negative 1y, which gives me 9x squared minus 16. And so when I factor these as 4x minus y, 9x squared minus 16, this right here is that difference in squares. And so we kind of have to be able to switch back to work that we did in our Algebra 1 review, where we factored that difference of squares. And again, the difference of squares, as we saw a few examples ago, earlier in the lesson here, or earlier in the review part, is since this is a difference of squares, we have the square root of 9x squared and the square root of 16, the square root of 9x squared and the square root of 16, and there's a plus 1 and a minus 1. All right? And so want to make sure that we are able to do that and to do it well, right? I want for us to be able to do this factor by grouping, and that's why I try to steer you guys away from the tic-tac-toes and the hangmans and stuff like that, so that we can focus on an appropriate way to do our algebra factoring. Folks, I do believe that is the end. Woohoo! And so hopefully you are able to factor a sum and difference of cubes. That factor by grouping is just an extension of work that you did back in Algebra 1 and that we did last semester. And so I'm very hopeful that you're going to have a lot of success with this lesson. It will require you to engage with those shortcuts, all right? Write those formulas down and make sure you're feeling good and groovy. See me with questions.